All right. Hello, everyone, and welcome back. Today, we are going to be picking up where we left off with radical expressions, and we are going to be adding and subtracting radical expressions. So, here's the thing with radicals. You can't just add them together. You can't just add any radicals together that you want. Two square roots that have the same radicand are what are called like radicals. So like radicals are two square roots that have the exact same number or expression inside them. So like radicals with the same number or expression inside them can be combined with addition or subtraction. And when you do the addition or subtraction, you're going to kind of treat the square root like a variable, and you will just combine their coefficients. So all you will do is you will add together the numbers in front and kind of treat that square root like you would a normal variable. So for example, if you have 2 square root of 3 plus 4 square root of 3, you might notice that these are both square roots, and there is a 3 underneath both square roots. So these are two square roots with the same radicand. They have the exact same thing underneath the square root. So these are examples of like radicals. So we're going to combine these just like we would combine a 2x plus a 4x. We're going to add together the numbers in front. So 2 plus 4 will give us 6 square root of 3. So 2 square roots of 3 plus 4 square roots of 3 will give us 6 square root of 3. And this can't simplify any further because, as you notice, square root of 3 is a prime number. You can't actually simplify that square root. So then for the next one, like radicals would have the same number or expression underneath the square root. So we have 6 square root of 2x minus 4 square root of 2x. You might notice that underneath each square root is a 2x. So because these two square roots have the exact same radicand, they are like radicals. So we're going to combine them just like we would if these were regular variables. So we're just going to combine their coefficients. 6 minus 4 gives us 2 square root of 2x. So 6 square root of 2x minus 4 square roots of 2x are 2 square roots of 2x. Now remember, you can only add or subtract like radicals. If the radicals are unlike, if the two radicals do not have the exact same thing underneath them, as they are written, they cannot be added or subtracted. So you can only add or subtract like radicals, just like you can only add or subtract like terms. So if the radicals are unlike, you might be able to turn them into like radicals by simplifying one or both of them. And this process is going to involve simplifying radicals like we covered in the last video. So for negative 8 root 12 plus square root of 3, at the moment, these two are not like radicals. So what we're going to do is we're going to simplify each radical first and see what happens. So I'm looking at this square root of 12 here. 12 does have a perfect square factor, so let's just simplify the square root of 12. And just because I don't have a whole lot of room, I'm going to do that off to the side here. So the perfect square that goes into 12 is 4, so I'm going to write 12 as 4 times 3. Split this up into two separate radicals, square root of 4 times square root of 3. Square root of 4 is 2, square root of 3 is just left as is. So square root of 12 can be simplified as 2 square root of 3. Now remember, there is hidden multiplication between that negative 8 and that square root. So I'm going to write this as negative 8 times. I just simplified square root of 12 as 2 square root of 3. Plus, now for this other term over here, square root of 3, that's as simplified as it's going to get, so I'm just going to leave it like that for now. Then negative 8 times 2 is negative 16 square root of 3. Plus, there's technically a 1 here, square root of 3. Now take a look at these two radicals. Notice how they have the exact same thing underneath them, square root of 3 and square root of 3. Now these are like radicals, so now that they are like radicals, now we're going to combine them by adding together the numbers in front. So we're going to take negative 16 plus 1 is negative 15 square root of 3. Please leave the square root of 3 alone. just like you would leave any other variable alone when you combine like terms. So then for this next one, again, you can only add or subtract like radicals. So at the moment, as these are written, these are not like radicals because there's an 8 in one of them and a 2 in the other. So what we're going to try is we're going to try and simplify at least the square root of 8 first and see what happens. So I'm going to simplify the square root of 8 off to the side over here. This square root of 2, it's not going to get any better, so that's as good as that's going to get. But let's simplify square root of 8. The perfect square factor that goes into 8 is 4, so 8 is 4 times 2. Going to separate this into the product of two separate radicals, so I have square root of 4 times square root of 2. Square root of 4 is 2. Square root of 2 is going to be left alone as square root of 2. So square root of 8 can simplify to 2 square root of 2. So again, remember there's hidden multiplication between that 4 and that square root, so I'm going to leave the 4 there, I'm going to leave the multiplication there, and I'm going to replace 8 with its simplified version, 2 square root of 2. Then we have minus 10 square root of 2 is not going to simplify any further than that. Then 4 times 2 will give us 8 square root of 2 minus 10 square roots of 2. Now that these two square roots have the exact same thing underneath them, they have the exact same radicand, these are like radicals. So since they are like radicals, we're going to combine them by subtracting their coefficients. So 8 minus 10 will be negative 2 square root of 2. So we're going to do the same idea with this. Now, as they are written, these are not like radicals because there's an 18x in one of them and a 32x in the other one. So what I'm going to do is I'm going to simplify the square root of 18x and the square root of 32x one at a time, and then I'm going to tackle actually simplifying this. So let's take square root of 18x. Again, I don't have a lot of room. I'm going to do this over here, and I'm going to simplify this. So remember, when you simplify square roots, you are looking for perfect square factors that go into 18. So the perfect square factor that goes into 18 is 9. 18 is 9 times 2. So I'm going to write 18x as 9 times 2x. Then I'm going to split this up into two separate radicals. I've got square root of 9 times the square root of 2x. Square root of 9 is 3. Now, since 2 is a prime number and the power on x is less than 2, this cannot simplify any further, so I'm going to be left with square root of 2x. So, square root of 18x here, I'm going to eventually replace that with 3 square root of 2x. Then I'm going to do the same thing to simplify this square root of 32x. And I'm going to do that over here. So we're going to look for a perfect square factor that goes into 32. The largest perfect square factor that goes into 32 is 16. So I'm going to write 32x as 16 times 2x. Then I'm going to separate this into two separate square roots. Square root of 16 times square root of 2x. Square root of 16 is 4. And since 2 is a prime number and the power on x is 1, which is less than 2, square root of 2x is going to be fully simplified. So I'm going to then replace square root of 32x with its simplified version for square root of 2x. Remember, there is hidden multiplication right there and right there. So I have 8 times replacing root 18x with 3 square root of 2x minus 2 times replacing root 32x with 4 square root of 2x. Multiplication always comes before subtraction, so I'm going to do this multiplication first. So 8 times 3 is 24 square root of 2x minus 2 times 4 is 8 square root of 2x. Now if you take a look at the square roots, we have square root of 2x, square root of 2x. These two square roots have the exact same thing underneath them, so they are now like radicals. Because these are like radicals, I'm going to combine them by subtracting their coefficients. 24 minus 8 is 16 square root of 2x. And then that is going to be my final answer. So then for this next one, remember, order of operations does always apply. So all of these are like radicals, which is great. So we have root 2, root 2, root 2. So they're all like radicals. When you have addition and subtraction in the same problem, remember, you are going to do them in the order that they appear when you read the problem from left to right. So when you read this problem from left to right, you see that the subtraction comes first, and then the addition. So let's go through and subtract from left to right first. So 5 root 2 minus 3 root 2 is 2 root 2. Then I'm going to add to it this plus 12 root 2. So 2 root 2 plus 12 root 2 is 14 root 2. And then that is going to be my final answer. So remember, addition and subtraction is always done in the order they appear when you read the problem from left to right. So then for this next one, we have 3 square root of 12 minus 5 square root of 27. These are not like radicals, so as they are written, you cannot subtract these. So before any subtracting happens, you need to simplify both of these square roots and see if you can turn them into like radicals. So I'm going to start with square root of 12. I'm going to simplify that over here off to the side. Square root of 12, well, 12 is 4 times 3. I'm going to separate this into the multiplication of two separate square roots, so square root of 4 times square root of 3. Square root of 4 is 2, square root of 3. So I'm going to eventually replace square root of 12 with its simplified version, 2 root 3. Then I'm going to do that again and do the same thing to simplify the square root of 27. So you're going to look for the perfect square factor that goes into 27, which is 9. 27 is 9 times 3. So I'm going to split this up into two separate radicals, square root of 9 times square root of 3. Square root of 9 is 3. Square root of 3 does not simplify any further. So I am going to then replace square root of 27 with its simplified version, 3 square root of 3. So let's actually go through and replace both of these radicals with their simplified version. So I've got this 3 still here, so 3 times, in place of root 12, I'm substituting 2 square root of 3, minus, leave the 5 times alone, and then I'm going to replace square root of 27 with 3 square root of 3. Multiplication comes before subtraction, so 3 times 2 is 6 square root of 3, minus 5 times 3 is 15 square root of 3. Now these are like radicals. Square root of 3 times square root of 3. The two square roots have the exact same radicand, so I'm going to then subtract them by subtracting their coefficients. So 6 minus 15 is negative 9 square root of 3, and then that is going to be my final answer. Now, just to point out, back here when you were multiplying, you can only multiply expressions that are not in square roots together and expressions that are in square roots together. So all you would be able to do here is the 3 times 2, which is 6, and you would just have to leave the square root of 3 alone. Same thing over here. You would do negative 5 times 3, which is negative 15, and you would have to leave that square root of 3 alone. So then for these next two, again, you can only simplify with addition and subtraction if you have like radicals. So for square root of 12x cubed and square root of 3x, these are obviously not like radicals, so we're going to have to do a little bit of simplifying first before we can actually subtract these. So let's take square root of 12x cubed and let's simplify it. So we've got the 12 to deal with and the x cubed to deal with. So 12 is going to be equal to 4 times 3. And then x cubed, since this power is higher than 2, that means this can be simplified. So we're going to write this in terms of as many x squareds as we possibly can. So I'm going to write x cubed as x squared times x to the power 1. Then I'm going to separate this into a whole bunch of radicals, square root of 4 times square root of 3 times square root of x squared times square root of x to the power 1. Then I'm going to do all of the square roots that I can. So square root of 4 is 2. Square root of 3 is going to be left alone. Then for the square root of x squared, remember when you have a square root and a square perform together at the same time, they're going to cancel each other out, leaving you with x times square root of x. Then I'm going to finish simplifying by multiplying everything that is not under a square root together. So 2 times x will give us 2x. Then I'm going to multiply everything that is under a square root together. Square root of 3 times square root of x is square root of 3x. So I'm going to replace this square root of 12x cubed with its simplified version, 2x square root of 3x. Now over here, for the other radical, 3 is a prime number and not a perfect square, so that's not going to simplify. This power on x is 1, so since the power on x is lower than 2, it cannot be simplified, so the square root of 3x here is actually fully simplified. So let's do some rewriting. I have 3 times, in place of square root of 12x cubed, I'm going to write its simplified version, 2x square root of 3x, and then minus 2x square root of 3x. So then 3 times 2x is 6x square root of 3x minus 2x square root of 3x. And these are actually like terms, because they have like radicals, square root of 3x, square root of 3x, and they both have an x in them. 6x and 2x are like terms. So we're going to subtract them like we would any other like terms. 6x square root of 3x minus 2x square root of 3x is 4x square root of 3x. And then for this last one, if you take a look at the radicals, 8y, 2x squared y, 32x squared y, none of those are like radicals. So let's simplify all of the radicals that we can, and then we're going to focus on the adding and subtracting. So let's start with the square root of 8y. 8 does have a perfect square factor. It is 4 times 2. Now, since that power on y is less than 2, that y is not going to simplify, so we're just going to leave it like this. So then we're going to separate this into 2 separate radicals. Square root of 4 times square root of 2y. Square root of 4 is 2, and then we have square root of 2y is not going to simplify any further. So I'm going to take this 2x, I'm going to leave it alone, and I'm going to replace that square root of 8y with its simplified version, 2 square root of 2y. Then I'm going to do that again to simplify 2x squared y. So square root of 2x squared y. Well, if you take a look at this, the 2 and the y are not going to simplify anymore because 2 is a prime number. The power on y is less than 1, so that's not, it's less than 2, so that's not going to simplify. But this x squared right here, remember, when you have a square root and a square perform together, they're going to cancel each other out. So I'm going to separate this into the square root of x squared times the square root of 2y. Now the square root of x squared, when those cancel each other out, will leave you with x times the square root of 2y. So for this next term, I'm going to leave the minus 3 alone, and I'm going to replace square root of 2x squared y with its simplified version, x square root of 2y. Then I'm going to do that a third time to simplify the square root of 32x squared y. So there's a lot going on here. So we've got 32, the largest perfect square factor that goes into 32 is 16. It is 16 times 2. X squared is already written in terms of a squared, so that will eventually cancel out. And since the power on y is currently less than 2, it cannot simplify any further. So I'm going to separate this into the square root of 16 times the square root of 2 times the square root of x squared times the square root of y. Then I'm going to do all of the square roots that I actually can. So square root of 16 is 4. Square root of 2 needs to be left alone. Then for the square root of x squared, the square and the square root will cancel each other out, leaving you with x. And then the square root of y is not going to get any better than that. Then let's simplify this by multiplying everything that is not in a square root together. So 4 times x is 4x. And then let's multiply the square roots together. Root 2 times root y is square root of 2y. So back over here, I'm going to leave that plus 2 alone. And I'm going to replace this root 32x squared y with its simplified version, 4x square root of 2y. Now multiplication comes before addition and subtraction, so let's clean this up by multiplying. So over here I have 2x times 2, which is 4x square root of 2y. Minus 3x square root of 2y is not going to get any better than that. Then plus 2 times 4x is 8x square root of 2y. And these are all like terms. So if you take a look at the radicals, square root of 2y, square root of 2y, square root of 2y. All three of these radicals have the exact same thing underneath them, so they are all like radicals. And each of these terms has an x in it, so these are all like terms. And remember, when you see addition and subtraction performed together, we're going to do them in the order they appear when we read this from left to right. So reading this from left to right, we're going to do the subtraction first. 4x root 2y minus 3x root 2y is 1x root 2y. Then we're going to add to it that 8x square root of 2y, which will give us x plus 8x is going to be 9x square root of 2y. And then that is going to be our final answer. So that is pretty much it with adding and subtracting radicals. Remember, you can only add or subtract like radicals, which have the same thing underneath the square roots. If you do not have like radicals, you need to simplify either one or both of them so that you rewrite them as like radicals and then add and subtract them. Remember, in order of operations, addition and subtraction always goes last. So adding and subtracting will actually be the last thing that you do. So thank you all very much for watching, and I will see you guys in the next video.